Folding screen.
Oh, yeah.
It's mutable partition. Change.
I give it back to you.
No, you need to give it back.
Eraser. Eraser.
You don't give it back. You give it to Peter.
Wait, no. In all fairness, I give it to Blair. He'd say, oh, thank you. That's math.
Wait, when's Zoom?
It's normally at the around the beginning of a month. Yeah, so not next week, but the following week.
No, I'm not gonna be here.
I always get confused.
I'm not gonna be here for Scott.
I do it one bit.
I'll come back to you so I can see Scott.
I do it one bit. So I don't have to.
I think you want more of it.
Because some people be like,
If you have to lift up, well, that's also why you want to go into it. Yeah.
except for 7, I do it.
What's the point of that?
You just can't. What's the point to not go?
But if you're gonna do.
Alright guys, let's take a look at page 322. We're going to take a look at these exponential graphs a little bit further today. I forget, did we finish the first one? Yeah. I think we graphed it, we did domain and range. Okay. Then we'll move on to number 2. Alright, so if we, first of all though, maybe let's look back at number 1. I know it's not complete up here, but you should have it in your notes. We kind of started off this graphical process by first thinking about what was the basic beginning exponential function that we start with. Can we think about how we can identify that? What should we be looking for in an equation to kind of think about the basic one that we started with? The base. Okay, so let's take a look at number 2. Can we label the basic function? 2 to the x. Okay, so either in your mind or on your paper, I want you to ignore that base of 2. Everything else, though, in that equation is some type of transformation or change. So we're going to have to take our time, take a look at what's left, and kind of pick apart what the actual change is. So can you look at the equation and can we start to label some? Yeah. Left 2. Okay. I like it. You want to keep going? Yeah. Down 5. Looks good. All right, so we reviewed those transformations yesterday. I think we had like 5 or 6 of them. And then using those transformations, we'll kind of identify what's happening in this equation. So with those transformations, can we write a coordinate rule, some type of little equation we can use to help us figure out where these new points are located? If we're moving left 2, which variable do we affect? Or if we're moving down 5, which variable do we affect? Want to keep going? Yeah. Y minus 5, minus plus. Yep. Looks good. So if you're moving to the left, your x value is getting smaller, meaning you're subtracting something. And if you're moving down, your y value, bless you, is getting smaller. So you should be subtracting, bless you, going for 3? No, not today. Did you think of me? Okay. Like Mrs. Bauer would be so impressed. Here you go. All right, so now that we have our coordinate rule, we need to think about what are some of the beginning points on this basic graph that we start with. Now, conveniently, this 2 to the x, we kind of investigated yesterday a little bit. We plugged in -2, -1, 0, 1, and 2. And if we just take a moment to plug those in, we'd get 1/4, 1/2, 1, 2, and 4. Let me ask you this, and I'm not sure if we covered this yesterday, but what if our basic function was 3 to the x? Can we possibly think about how these y coordinates would change? Yeah. A ninth, a third. Yep.
And 3 and then
139. Yep. Okay, so I know that this 2 to the x is something we looked at yesterday, but even if we change the base to something else that we didn't cover yesterday, we can still think about these beginning points. Okay, they're supposed to be easy to find because this is a very basic beginning function. So now that we have the beginning points, we're going to plug them in to our coordinate rule that we created from the transformations, and we'll find our new coordinates for this k of x equation that we're trying to graph. So we're going to take the time and plug each x and y in to get our new coordinate. Once you have your coordinates, take a few moments to plot them. And before we play connect the dots, it might be beneficial for us to also label where the horizontal asymptote is, because after all, it is a graphical characteristic. Can we identify where that's located? Maybe you can tell from the ordered pairs. Maybe you can tell from the equation. Go ahead, Lizzie. -5. How'd you know? Okay, so notice how on the points, these ending y values are really close to -5. We're getting closer and closer. Alicia, were you going to say something else?
I was going to say
Same thing. Did you look at the points?
I just looked at the equation.
All right, so where's it in the equation?
The constant.
The constant on the end. There you go. All right, so you can look at different information that we found so far to help us with that horizontal asymptote spot. So we'll throw that in. So you have to play connect the dots, but do not go past the asymptote. So something like that. Looks good. While we're at it, since we have a graph, let's go ahead and practice our domain and range. If you were to trace it left to right, low to high. What do we think for domain? All real numbers. Okay, what about the range? Bless you. -5 to infinity. Looks good. All right. So the one we just did today and number 1 that we finished yesterday were 2 examples of a base that was bigger than 1. Okay, we had 2 in each of those cases. Let's go ahead and take a look at a few more today, but this time perhaps we'll have a base between 0 and 1. All right, so if we look at the equation, the base is 1/2. So our basic beginning equation would just be 1/2 to the x. So in your head, I want you to ignore the 1/2 or maybe cross it off on your paper. Everything else is some type of change that we have to identify. So can we pick it apart? Good, Lizzie? All right, how'd you know that? All right, negative out front, in front of the base. Looks good. Good, Alicia?
Right 2.
Right 2, which one were you looking at? Because there's 2 2's in there.
Oh, the exponent.
The exponent. Okay, so right 2 is in the exponent spot. What about the 2 on the end? Good, Caitlin? Up to. Good. All right, I'd say that's pretty good. With those transformations, let's write our rule, how the coordinates from the basic graph would change into the coordinates of this new graph. Let's see, x-axis flip. Which variable does that affect? The y, and what happens to the y? It becomes negative, okay. Right 2, It'll be a plus 2 on the x, and then up to plus 2 on the y. All right, so somehow we're going to take a few points from this basic beginning graph, and then we'll change them into the points for our new graph. Now, again, we looked at a base of a half yesterday. We developed a table for it. And we kind of had the same outputs as if our base was 2, but this time they were in the reverse order. Kind of makes sense because we reversed or flipped the base. All right, so we're going to take a few moments to plug in those values into our coordinate rule, and we'll get our new points. All right, so plot your points. Also label that horizontal asymptote. Looks like we have 2 in this case. So you have to play connect the dots, but do not go past the asymptote. All right, so there's our exponential graph. Can we label domain and range? Let's see, if I trace it left to right, I don't really have any holes, jumps, or asymptotes to worry about. So all real numbers for domain. What about the range? Low to high. Negative infinity to 2. Looks good. All right, do you guys think you can try 4 on your own? Give it a shot. See how far you can get. We'll check it out in a little bit. All right, it's looking good, guys. Let's see. Looking at the base, it's a half, so we know what our basic equation was. Can we pick apart the rest of the equation, though, to find some transformations? What did you guys list? What, Alicia?
Both x and y axis flipped.
All right, can you separate them for us? Which one is x and which one is y?
The y axis flipped is the negative x and 16.
Okay.
And then the x axis flipped is the negative 3.
Out front. Okay, so x-axis out front, y-axis in the power. Looks good. There's some other ones. Go ahead, Noah.
It goes right through and down one.
All right, how'd you get right 3?
Since it's in the exponent, it's a negative x, which means it's not the opposite.
It's not the opposite. Yep. So we have that double negative, okay? If the power was just x plus 3, it would go left. But since the negative is in the power spot as well, it kind of flips it or changes it, so it's actually going to go right. So when you have that kind of double negative component, notice how if it is a plus 3, it's going to go right. Okay, a little tricky. And then down 1 looks good. Can we use those to help us write a coordinate rule? Can we think about how each change would affect either an x or a y value? What do you think, Caitlin?
Negative x plus 3
Okay.
and negative y minus 1.
I love it. Okay, so x-axis flip changes or negates a y value. A y-axis flip negates an x value. Right 3 increases an x and down 1 decreases a y. Looks good. So since we have the same basic 1/2 to the x equation as we did for the last example, we can go ahead and use those same beginning points. We just got to take these and plug them into our new coordinate rule. So let's see, 5, negative 5, 4, negative 3, 3, negative 2, 2, negative 1.5, 1, negative 1.25. All right, so let's plot them. All right, don't forget your horizontal asymptote as well. We have that constant on the end of negative 1. So we'll play connect the dots, not going past the asymptote. How is your graph? Perfect? All right, domain and range. Not sure, but maybe you've seen a pattern so far with these exponential functions. What's the domain? All real numbers. Okay, that's going to be for every exponential function, all real numbers. But notice how the range changes, though, depending on where the asymptote is and whether you're above it or below it. So we have to be a little particular about that one. In this case, negative infinity to negative 1. 2 thumbs way up. Awesome. Okay. We're going to call it a day. I know we still have about half the period left, but go ahead and use it for some homework time and question time. I'd rather start our next section on a full class period. Okay, instead of getting chopped off in the middle and then you guys have a weekend.